All right, so here we are. We're picking up with number 4 on our third 9 weeks review in third period now. So who wants to read number 4? Jacob.
The table shows the hours worked by employees at a coffee shop last month. What is the ratio of Jamie's hours worked to Maya's hours worked if the total hours worked for all employees is 7M plus 19?
Well, I kind of like how you said equals because that's exactly what that means. So we're going to take all of these hours, we're going to add them up, and we're going to set them equal to this right here. So let's go ahead and get started with that part. We have 48 plus 2M plus 7 plus 3.5 times M minus 6 plus M, and all of that is equal to a 7M plus 19. What do we have to do first before we can start combining our like terms so that we can solve for M? What do we have to do first? Anybody? Christian? We got to distribute, right. We got to distribute that 3.5 throughout everything inside, and when we distribute, we're using what mathematical operation?
Distributive property of
Multiplication. All right, good. So we've got 48 plus 2M plus 7, and then 3.5 times M gives us what? A 3.5 M. And 3.5 times a negative 6. Now, if I don't know this off the top of my head, I'm going to get my calculator out because I am allowed to use that this year on the STAR. And I'm going to take 3.5 times negative 6, plug it into my calculator, and what do you get? Yes?
Negative 21.
Negative 21 plus M, and all of that is still equal to 7M plus 19. All right, so now can we go ahead and start combining our like terms? You bet. So let's start with our integers. We've got a 48, and what we're going to do is we're going to start plugging it into our calculator. We have 48 plus 7 minus 21, right? Minus 21. So what do you get? Devin, what do you get? 48 plus 7 minus 21. Christian.
34.
Positive 34.
34.
Too slow. You should have your calculator out and ready to go.
I don't know.
All right, good. So we've taken care of those. So now we've got 2M plus a 3.5. So 2 plus 3.5 plus, and then we've got this 1M sitting over here. What's that? 1 plus 1. Okay, so 2 plus 3.5 plus 1 gives us what?
6.5.
6.5M. Okay, good. So now we have all of our things combined, our like terms combined over here. So now what? Now we can start solving, right? So we want to start getting all of our variables on one side and all of our integers on the other. So where do you want to start? We want to keep our variables positive. So how do we do that? What do you suggest? Subtract 6.5M from both sides. 6.5M minus 6.5M, which gives us 34 on this side of the equation. And what are we left with on the other side? A 0.5M. Now, what should we do? Subtract 19 from both sides. Thank you, Christian. And so then that leaves us with 15 over here and a 0.5M over here. We divide both sides by 0.5, and what do we get? Find out that M is actually equal to what? Yeah, Jacob?
30.
30. So now what does M represent for us? Do you remember?
Maya.
May, right? It equals May's hours. Okay, so that's her hours. So M equals 30. Now, but what about Jamie? Because we were asked to write a ratio of Jamie's hours to May's hours. So what are Jamie's hours then? We're going to have to plug in the 30 into our equation here, our expression that we have for Jamie's hours. And so 30 minus 6 is what? 24. So we're going to multiply 3.5 by 24, and we find out that Jamie worked how many hours? 84 hours. Okay, so he worked 84, and she worked 30. So a ratio of their hours would be 84 to 30, or 84 over 30. Can I reduce this at all? I can, right? So first, if we just start dividing everything by 2, we wind up with what?
42 and 15.
42 over 15. And then can I reduce that again?
No.
Yes, I can. I can reduce again by 3. And I'm left with what? 14 and
Over 5.
5. So our answer is either 14 over 5 or 14 to 5. So what does that mean, that ratio? For every 5 hours he worked, he worked how many? 14. Okay. All right, next problem. Let's see, number 5. Everybody good with this one? It's going to go away. All right. Number 5, it says to graph each linear equation and give the solution to the system. All right, so we need to point some things out here. Taking a look at this equation and this equation. Both equations are in what form? Yes, slope-intercept, because we can easily see the slope and we can easily see the intercept. So let's take a look at this equation first. Tell me what the y-intercept is for that first equation. Jacob? -2. So that means we have a point at 0, -2, because we know that the y-intercept is the value for y when x is equal to 0. And what is the slope of that line? It's our coefficient in front of x, right? So what did you say it is, Shelby? -2. Our slope is -2, and I'm going to write it like this. Why do you think I'm writing it like that? Rise over run. It's going to help us to graph it, right? Okay. So, what about this line? What's our y-intercept here? It is a +4, so that means we have a point at 0, +4. It's the value for y when x is 0. And what's the slope of that line? It's not 0, because think about it like this. X times 0 would give you what? 0, right? So that means if our slope was 0, then we wouldn't even have an x there. But if our slope is 1, then we would have what? An x there. Okay, so our slope is 1, and I'm going to write it like that, 1 over 1. We have one line with a positive slope and one line with a negative slope. Everybody see that? That means when we graph it, we should easily be able to see, does our line go up from left to right or down from left to right, depending on if it's positive or negative. So let's graph this first one. So 0, -2. So we start here at 0 for x. We're not going to go anywhere, and then we're going to go down to -2. 1, 2. So there's our first line, our first point on our first line. And then we're going to use our slope to graph it. It's going to be negative, so we know that our line needs to go down from left to right. So we're going to go down 2 and over 1. And I can't really go down 2 and over 1 anymore, but if I go back to my original point, if I go up 2 and I go over to the left 1, because it's negative, then I can see my line. Now I can go ahead and connect those dots, and I can see that I have a negative sloped line, right? Everybody good with this one so far? I'm going to add just another couple of points here. Let's see, let's go up 1, 2, and over 1 more. So we have one right there that kind of fills in our line. And then I'm going to add arrows because it could go on and on. All right, now let's graph the other line. And I'm going to use a different color only because I really want to be, well, no, I don't have to. All right, so 0 and 4. So I'm going to start at the point of origin again, and I'm not going to go anywhere on the x-axis, but I'm going to go which way to graph that point, 0, 4. Up, 1, 2, 3, 4. And this one has a positive slope. That means our line is going up from left to right. So I go up 1 and over 1 using my slope, but now I'm kind of stopped, right? Can't go anywhere else. So, but I could go down 1 and over 1, down 1 and over 1. I've already got a point there. Down 1 and over 1. Now I could go ahead and connect those dots. And it kind of, well, sort of, pretending. Our imaginations are great. So we can see that both of them have that point in common. That means, therefore, that is the what? That is the what?
Line of intercept.
That is where they intersect, but it's not a line of it is our solution. The reason why that is a solution at -2, +2 is because that is the one point that both of those lines have in common. It's the one and only point that they both have in common. So therefore, that's the solution. Any questions about that? We could probably get through maybe one more question, and then our video is over. Went fast, didn't it? All right, number 6. Mountain climber A is at an altitude of 250 feet and is descending at a rate of 30 feet per hour. So that would look like 250, and it's descending. Would it be addition or subtraction? Subtraction. Descending at a rate of what? 30 feet per hour. Okay, and then it says mountain climber B is at an altitude of 400 feet, and it is descending, so subtraction again, right? At what rate? 50 feet per hour. And they ask us, in how many hours will the altitude of mountain climber B be lower than the altitude of mountain climber A? So I need to know, based on that information, am I going to put a greater than symbol here, a less than symbol here? Which one? A greater than, right? Because they want to know when B is going to be less than this guy over here. This is A, and this is B. Everybody good so far? All right. I think we could probably get one more in, actually. Let's take a look at number 7. Ooh, number 7. All right, so first I need the equation to solve this. It's a cone, and then we're looking for the volume. So volume of a cone is what? Pi times radius squared times the height divided by 3. Okay, so let's take a look. What's our radius? It's half of 5.5, so 2.75, right? And what's our height? 11.2. Okay, so we're going to plug all those things in. So we have V is equal to pi times 2.75 squared times 11.2, and all of that divided by 3. When you plug all of that into your calculator, what do you get? Shelby? 86.6. You get 86.6 and what? But you get more than that. Anybody else got something else? You get 86 point something, 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 something. 698, something like that, right? What'd you get, Jacob?
I got 266.
Nope. Double check your answer. 88 point what? 697. Okay, but it says round to the nearest tenth, so we get 88 point what? 7. And what's our unit of measure? Millimeters cubed, because it's volume. Wonderful. We are going to stop there.